EMF induced by changing the orientation of the coil. PQRS is a rectangular coil of N turns and area A placed in a uniform magnetic field B. The coil is rotated with an angular velocity omega in the clockwise direction about an axis perpendicular to the direction of the magnetic field. Suppose initially the coil is in vertical position so that the angle between normal to the plane of the coil and the magnetic field is 0. After a time t, let theta is equal to omega t be the angle through which the coil is rotated. If phi is the flux linked with the coil at this instant, then phi is equal to NBA cos theta. The induced EMF is E is equal to minus d phi by dt is equal to minus NBA into d by dt cos omega t. Therefore, E is equal to NBA omega into sin omega t. This is equation 1. The maximum value of the induced EMF is E naught is equal to NAB omega. Hence, the induced EMF can be represented as E is equal to E naught sin omega t. The induced EMF E varies sinusoidally with time t and the frequency being nu cycles per second. Nu is equal to omega by 2 pi. When omega t is equal to 0, the plane of the coil is perpendicular to the field B and hence E is equal to 0. When omega t is equal to pi by 2, the plane of the coil is parallel to B and hence E is equal to E naught. When omega t is equal to pi, the plane of the coil is at right angle to B and hence E is equal to 0. When omega t is equal to 3 pi by 2, the plane of the coil is again parallel to B and then induced EMF is E is equal to minus E naught. When omega t is equal to 2 pi, the plane of the coil is again perpendicular to B and hence E is equal to 0. If the ends of the coil are connected to an external circuit through a resistance R, current flows through the circuit, which is also sinusoidal in nature.